So here you see we have 1,126. So now we're down from 100,000 to 1,000, and we're confident that this data at least isn't too bad, and this is the kind of thing you should analyze. All right. So now that we know why we're processing data and what it means to process data, let's process some data, which means it's time for Britney. We're still on Zoom.
Not so great. So I wanted to quickly show the steps of the data processing as we do it now. So we mentioned, okay, we're using speed. I took some speed recommendations from a work that John Fulton did, looking at the min and max speed of the yield monitor that we would trust. And then also detecting overlap, particularly overlap. So first thing we're building polygons around all of our data, the harvest data as applied, as planted. And we are using the swath width as reported by the monitors. And sometimes the yield monitor, it seems to be recognizing, right, that there was overlap and adjusting the swath width, but sometimes it's not. So if we see overlap in the data, we're removing. Overlap and yield data. I mean, we have the yield polygons they drove in the same place twice, right? So we're seeing that a lot in the headlands, and of course that's why we're removing them. But we can also see it in the middle of the field if they went for lunch and came back. So we want to remove those polygons that came later. And then so we have these, first we're removing the outliers as we said, for if there's an outlying yield observation, or if there's an outlying speed, or if the direction is changing very rapidly. Then we are overlaying the different layers. So you may have a seed application and a nitrogen application. And we make the final units of observation groups of yield polygons. So we want to know, okay, we had some outlying as applied polygons here. And let's enlarge this. It's a lot, I don't have a pointer, but it's easier to see when we enlarge the yield observation, the red polygons are the yield observations here. That all of these yield observations are about half in a lower seeding rate, half in a higher seeding rate. And I did some simulations in my dissertation showing that when we mix the yield observations from the high and low yield, or high and low input rate, that it does affect our estimated optimal nitrogen or seeding rates. So we really shouldn't be including these in our final data set. So that's one thing that we're removing. The other is when we start grouping the yield polygons. We don't want to group yield polygons where the applied rate was changing rapidly. So in order to remove those transition zones, we also have a max jump for the two yield polygons to be considered in the same final group when we aggregate them. So all of these here, it's hard to see, but these red yield polygons, it went from like a medium rate to a low rate to the highest rate. So all of these won't be in the final data set because that was a transition area. Whereas these are the final observation. So these are all in a group. This green group is one group that received the highest, and then the purple and, well, magenta and then purple. And then this is an example of a field that turned out very nicely. You can see the transition zones of the plots have been removed. And you can see real white verticals. Yeah. That's what we took that data because you were saying, oh, then you change. Yeah. We can't do that right. And this is the current version. There are a lot of adjustments and improvements that could be made, but this is done automatically, which is very nice for the research assistant. matched up perfectly, say with the trial designs, then you could just remove, say, the first 30 feet of every trial plot. And we used to do things like that, but we just had so many where, say, everything was shifted or there was misalignment. That's why we started moving to using the yield polygons as a unit of observation. It was hard to do it in a, but that was our first try,
So Brittany, years ago when we were doing fixed wing drone flights and we were 400 feet elevation going across the fields, we always had wind and things like that, and the drones would actually sacrifice their flight pattern to get the image. And the software that they were using then was actually like, you have like 4 or 5 different images overlapping each other.
Yeah.
And it was changing how they overlap. So their software would actually filter that and focus it, and it would kind of take out the blur of the overlap. Is that something that technically, like if the plots are drifting 10 feet one way or 10 feet the other, you can just simply focus it back in that same type of GIS reference focus?
No.
Yeah.
It's really depth, right? Difference in unity and depth. So it's not just a matter of taking an image, you're trying to measure something.
I'm just saying from the perspective of a combine, because the combine say has a 3-second to a 12-second lag.
Okay.
If we know that buffer, we can actually use it to filter.
Yeah.
Like if it's stretching the data or pulling it out of the polygon, we can pull it back, right? Like a focus.
I can imagine trying to use all the data to adjust bandwidth. That's
Sure.
Right. That's something here.
That's pretty deep.
Yeah, that's good.
Yeah, I mean, I hesitate for us to try to do everything because in my experience, there are some people we've worked with who really have thought a lot about yield maps. And I don't know that it makes sense for me to write an algorithm that they may have already created. So I think in some ways I want to link up with people who've already been working on improving yield maps.
I guess
If
that's
that,
part of
yeah.
How do you change
Yeah.
it? Does it kind of like, is it run parallel with what we're trying to do, or is it kind of overlap, or?
Oh, I think
Could be different technology.
I mean, the working with the people who are interested in improving yield maps, I mean, it's very much important to what we are doing, right? Because having quality output, it's integral to what we are.
Like 4K, right? It'll just have this ultimate, no more white lines, no more skits, no more, right? It would filter that.
Yeah, and that's what we're trying to do.
Yeah.
We end up trying to outliers right now.
Yeah, and there are some things that, so even if we can improve the quality of the yield maps, if they were harvesting from 2 different trial rates, it doesn't matter how good the yield data was, we still have to throw that out, right? So there are some losses that we can mitigate by working with farmers better, making plots wider, but that can still happen.
That we have to have, our system has to help farmers start in the right place. To say, oh, this isn't where you're supposed to start. Right. All these kind of things. We need to try to make this as easy as possible. And they're warning them so that it's probably in the ground right. And that people can happen with. So,
Yeah, I think that's where we as consultants kind of come in on, because we know how they're in the search field, we know, because like when I was paying on this, we actually laid the AV lines down and we were looking at overlap and overlap percentages per application.
It's not design software that says, okay, here's your AV line, this is what you're gonna get. And then it's all knows what you should look at. And help the farmer get it started. I don't like that because I want to start get great. You've never done that.
Another part of the issue is that when we develop AV lines for the plot, we want them to start on the plot. You know, if they're gonna start on the edge of the field, like they want to do, they're not gonna line up exactly in the middle of where we want them to drive through the pass.
Yeah.
So that's a little counterintuitive to the farmer. You want me to cut over here and then, you know, cut away from the edge of the plot? Yeah, we want you to go on this AV line because it's important. But you get in the field, there's no in the plot. So that's a bit of a challenge to kind of.
Yeah.
They're all in the field, some guys do their work.
Another question on maybe lines. You can suggest maybe lines or use that line. Or use it, is it freedom for you to suggest use an maybe line or the reason I'm asking that is if that is the case, then decisions will top for that. So on all these machines, you only have one piece of information about the business. The rest is computed. But and the geometry involved is that line is at the end. But if it's too low, then
Yeah.
Well, I'm trying to figure what you mean as far as so the optimal alignment with the field boundary using a different geometry rather than using one, just design everything either to north.
I'm saying people who know there's higher precision in all the quality of the
I think that our philosophy so far is strategy, not make the formal change. Thanks.
Yeah.
We want them to do what they usually do. So if they're unique, and a lot of times they want it 91 degrees, we don't want to switch that. And there's probably a reason why they do it. So
the 89 is the position of the 89, not the orientation of the 89.
so 89 has to understand.
I know that,
But-
Yeah, I mean, our suggestion is the AV line that they developed is going to go down the middle of the first pass we want to take. And
regardless of the direction.
well,
Yes.
the field boundary may be irregular, right?
Mm.
But the plot design may be rectangular and is here and there. Where they start is very important because that will affect the precision of the data as they go across the field. So they're going to have some skid backs, I guess you might say, because they field boundary edges or irregularly shaped. So it's going to cause them a little bit of discomfort, I guess, because not to be like the normally do it. It's important that we have a place that they start and maintain that across the field. And it can be that, it doesn't have to be short.
Yeah.
What the best configuration is, depending on whether the field is white or north south, or angles to the northeast, or yeah.
We got lots of time. So,
Yeah.
The bottom line is that Congress ends up doing what he wants sometimes.
The first introduction of variability into this whole program is the bar.
Yeah.
we know that.
So
Jesse?
kind of expanding on that observation. So like, you have a process here, there's an idea I want to test on one end, the other we have a results. The ball intelligence put into that, in those 2 points. And it sounds like you're trying to put as much intelligence as possible into the back end.
Yes.
Take it off of the farmer's shoulder.
Yeah.
We want to make it less big from, right?
I guess my concern is, where does that become so complex on your end that it becomes hard to maintain, or the software is so sophisticated that it's hard for the farmer to use, to make it easier and actually.
Yeah. Well, we're trying to have a straight on that.
We're making it, so.
Yeah, and you know, and the question too is, you know, at some point, do we back off on the back end and instead say we produce some nice instructional videos and things for crop consultants and farmers to use? I don't know. I thought a lot about that. Could we produce some nice videos explaining why AB lines are important and what a proper alignment looks like? I don't know. This is something like certainly the crop consultants and farmers in the room could tell me what you prefer.
We envision training workshops for
Yeah.
consultants where they come for a day, you know, and play with them, do things. You know, that's that's what we're aiming at. That level of expertise. Obviously, farmers can come for it. Plenty of farmers, no problem. But we're aiming our level, we're aiming, you know, level of training to really do this stuff. Now, some people, you know, they're not doing this kind of stuff, but that's, at least now, that's what they'll do.
Oh, I actually naturally am thinking about video production, this project, and so as we think about that conversation, from what I understand, people have about a minute and a half to maybe 2 minutes of attention span.
Yeah.
And then variation and equipment type,
Mhm.
colors, is it green or is it red or like whatever. So as we think about making videos, I would love to try and think our video making. Would really love to hear feedback as to what level of detail is useful to the growers, like what is plausible to actually accomplish within that kind of time frame.
Yeah.
And across the extreme understanding that this is applicable because the input varies, the equipment
Yes.
varies, the cropping system varies, like, you know, the peach planter versus the corn harvester thing that y'all do in the Midwest.
Yeah.
So what does that look like? So I'd love to explore and have that more of that conversation.
That is the thing, it's in cornholes.
Yeah, I would also love those conversations to happen.
Right.
Yeah.
Let's do that.
So what I'm here to present is actually this. This is just a beta version of what we want the site to look like for a producer, for a crop consultant to go in. And so you would log in, and ideally this would be linked to that trial design site that we saw yesterday. So you designed a trial, and now you're going to log in and you have a list of your trials. And maybe if you are a farmer, this would look a little different than if you're a crop consultant, where it's going to be grouped into the farms that you manage as well. And it gives you a status. So the 2023 trial is designed, and I can view that trial. And now it shows the trial design for this year. I'm sorry that the text is so small for all of you. And it gives you those trial parameters that you used for designing this trial. So, and once again, it shows the status. So it tells you you're missing the trial data. Of course, I'm missing the trial data because this is a 2023 trial. But it shows you where you would upload your as applied map and where you would upload your yield map. And if we go back, say, to 2021, this one is already complete. And we have our trial design from 2021, and you can actually view where you previously uploaded the raw yield and raw as applied. So I can view this, and it shows me the raw yield map next to that trial design map.
You can see on there.
Oh, yep.
You can see little rectangles. And actually, this is one where you can kind of eyeball the impact of the nitrogen.
And the same thing with the as applied file. Here, I need to zoom in. Oh, not that much. We'll do it this way. So what I wanted to do here, I'm sorry, is not just have the comparison of the as applied and the target right here, but I create a figure of how accurate was the implementation of the trial that we designed. And this might give us feedback about how large we want the jumps to be in the next year if we see that the applicator was struggling, say, to reach the highest or lowest rates. In this case, I need to zoom out a bit so you can see. This one, on average, performed pretty well. So when it was 18, really the mean is at 18 gallons of nitrogen. And you can view the process data. So view the final data set after you cleaned it the way that we were presenting. So you can view the as applied nitrogen map, the yield map, and you could view other characteristics. I mean, the final version would probably have many different drop downs, but you could look at something like slope, or if you had an electrical conductivity or soil test, you would be able to view those maps as well. And say you want to download the shapefile with your process data and say maybe a data preview of the first 5 to 10 observations in the data set.
So you don't have some accountability, once you have a decision tool, then you want to see a scatter plot.
Mhm.
By, field, and you want to see it in the northwest corner. Should be able to do that, but if you want, you should just download this data and play with it, with other programs that.
And so this one will just show what it would look like. Say it's the 2022 trial and you haven't uploaded your raw yield yet. So say you want to upload the raw yield for test farm field 1. So you would submit your raw yield and then submit it for processing. And then after some time, yeah, we can view the process data for this year. So it same, if you could see better, you would see where the transition zones in the nitrogen application were removed and the yield and slope and so on. So this is the idea. Right now, this is all written in our scripts, and so my job is to help Keith put all of this to work within his database that he's presenting after lunch.
I have a question, is that our shiny?
No, this was made, I don't even know what they used for this. This is a soft, yeah, like this is movie magic of what we want this to look like, right? So this is, yeah, the R Shiny tool is yesterday's trial design tool. That is on R Shiny, and that's why, and it crashes if too many people use it.
So when you upload the data into this, is it already scrubbed or is this gonna do the?
No, this would do the, yeah, that's the idea. So, and to connect.
Right, and so,
One other question, David. Is that artwork on the wall based upon what you're saying?
I was thinking.
You know, the joke that my husband says is that I design rugs. That's what he tells people I do. So, but but yeah, the grand vision is that site that we used yesterday that is fully functional using the R code to design the trials would be, that's going into Keith's database. And then this site is communicating with the database. So that's how it's telling the farmer, these are your trials for the year. Here's where you would upload the new files. Yeah.
And people say, well, my understanding, we don't have to get it far. There's historical systems, they were different things.
Yeah. Yeah, and that's another task, right? Looking at what we've created in R and talking to Keith about what the capabilities are of his database and where can we save time, work more efficiently by moving some of it from R into, say, SQL. Yeah. Okay.